right, so today we're working on chapter 4, lesson 4, equations as relations. So, what we're going to learn today is how to use an equation to determine the range for a given domain, and then we're going to learn how to graph the solution set for a given domain. So, some of the vocabulary to keep in mind is equations in two variables and solution. So, why are equations of relations important in traveling? So, during the summer, Eric will be taking a trip to England. He has saved $500 for this trip, and he wants to find out how much it will be worth in British pounds sterling. So, British pounds are the currency that they use in England. We use dollars, they use pounds. The exchange rate today is $1 equals 0.69 pounds. Eric can use the equation P equals 0.69 times D to convert dollars D to pounds P. So if I take the number of dollars, multiply it by 0.69, that will give me equal to how many pounds that's worth. So solving equations. So the equation P equals 0.69D is an example of an equation in two variables. Hint, hint, because there are two variables, P and D. A solution of an equation in two variables is an ordered pair, right? It's a pair that results in a true statement when substituted into the equation. So a number for P and a number for D that makes this equation true is considered a solution. So this solution is actually two numbers, one number for the P and one number for D that makes the equation true. So let's take a look. So it says, example one, solve using a replacement set. So it says, find the solution set for y equals 2x plus 3, given the replacement set, and they give you a set of ordered pairs. So here they give you an equation in two variables. The two variables are x and y, right? And they give you 1, 2, 3, 4 sets of ordered pairs. And remember, each ordered pair represents an x coordinate and a y coordinate. So we're going to make a table, and we're going to substitute each one of these each one of these values into the variables for the equation. So let's go ahead and take a look. So here's our table. Again, my x and my y coordinates, the equation when I put the values in, and then if it's true or false. So let's take the first point. So the first point has an x coordinate of -2, a y coordinate of -1. So I'm going to put these two values in for their respective variables. So my x is going to become -2, and my y is going to become -1. So -1 equals 2 times -2 plus 3. Well, I know 2 times -2 is -4, and then -4 plus 3 is -1. So now I see that -1 equals -1. So when I substituted in these x and y values, it gave me a true statement. So therefore, this is part of the solution. Let's look at the second point, an x value of -1, a y value of 3. Let's go ahead and substitute them into the equation for x and y. And then we're going to calculate them out. So 2 times -1 is -2, plus 3 is 1. Does 3 equal 1? That's false. So this one did not work. Let's look at the next one. 0 for my x value, 4 for my y value. Substitute them into the equation, right, for x and y. And 2 times 0 is 0, and 0 plus 3 is 3. So does 4 equal 3? It does not. That is also false. So let's move on to the last one. X coordinate of 3, y coordinate of 9. Plug them into the equation. 2 times 3 is 6. 6 plus 3 is 9. Does 9 equal 9? Yes, it does. That does give me a true statement. Therefore, the ordered pairs, -2, -1, and 3, 9, since they result as true statements, then the solution set is these 2 points. So they gave me 4 ordered pairs to try, and these are the 2 that worked. So that would be the solution set, is those 2 ordered pairs. So since the solutions of an equation in two variables are ordered pairs, the equation describes a relation. So in an equation involving x and y, the set of x values is the domain and the corresponding y values is the range. So let's look at an example. It says solve using a given domain. So here they give me an equation. Solve b equals a plus 5 if the domain is -3, -1, 0, 2, 4. And if you remember from previous lessons, the domain are my x values, right? Well, if you notice, there are no x's here. It's a and b. But here's a little tip for you. Unless the variables are chosen to represent real quantities, when variables other than x and y are used, like here, they're using variables other than x and y, assume that the letter that comes first in the alphabet is the domain. So you know how x comes first and y comes second? Well, same thing here. A comes first, B comes second. So A will be my domain. So these are the numbers that I'm going to be plugging in for A to find out what the corresponding ordered pair is for the B value, or what would normally be my Y value. So let's make a table. The values of A come from the domain, so these are going to be my A values. And we're going to substitute each value of A into the equation to determine the values of B in the range. So let's try -3, right? Here's our first value for A, -3. I'm going to plug it into the equation. So it's going to be -3 plus 5. What's -3 plus 5? That's 2. So I know that B has to equal 2, right? So now I know that ordered pair is -3, 2. Let's try the next one, -1. So I'm going to plug -1 in for A. So that's going to be -1 plus 5, which is 4. So then the next ordered pair would be -1, 4, right? X and Y, A and B. The next number in my domain is 0. So I'm going to put 0 in for A. So 0 plus 5 is 5. So my ordered pair is 0, 5. Next is 2. So I'm going to put 2 in for A. 2 plus 5 is 7. So then my ordered pair would be 2, 7. Finally, my last number in my domain is 4. Again, we're going to substitute it in for A. 4 plus 5 is 9. And my final coordinate is 4, 9. So again, the domain I plug in for um, my A values to get my B values. Again, this is typically like your X values and your Y values, right? Your domain and your range. And those are what make up your ordered pairs. So the solution set for this problem would be the 1, 2, 3, 4, 5 ordered pairs that I got from using the 5 numbers in my domain to find the 5 numbers in our range to come up with these 5 ordered pairs. Let's look at this. So graph solution sets. You can graph the ordered pairs in a solution set for an equation in 2 variables. The domain contains values represented by the independent variable. The range contains the corresponding values represented by the dependent variable. So let's go ahead and graph and solve a solution set. So it says solve 4x plus 2y equals 10 if the domain is -1, 0, 2, 4. So again, this is my domain, right? So these are going to be my x values. So let's go ahead. First, I'm going to go ahead and take this equation. I'm going to solve it for y, get y all by itself. And so here's my original equation. So if I wanted to get y by itself, I would start by subtracting 4x from each side. And that would give me 2y equals 10 minus 4x. And then I would divide both sides by 2. And then that would give me y equals 5 minus 2x. The main reason for doing this is now I can plug in numbers for, or substitute numbers in for x, and it's really easy to figure out what y equals. So let's go ahead and do that. So I'm going to first substitute the values in. I'm going to make a table. So here's my first x value, my first value of my domain, -1. I'm going to plug it into the equation for x. So 5 minus 2 times -1. So I'm going to multiply -2 times -1, which is +2. So it's like 5 plus 2, which is 7. So my first value is, my first ordered pair is going to be -1, 7. Then I'm going to do 0, the next value in my domain. So I'm going to plug 0 in for x. 2 times 0 is 0. 5 minus 0 is 5. So the next ordered pair is 0, 5. Third is in the domain is 2. So I'm going to substitute 2 in for my x. 2 times 2 is 4. 5 minus 4 is 1. So the next ordered pair is 2, 1. Finally, the last number of my domain is 4. I'm going to substitute 4 in for x. 2 times 4 is 8. 5 minus 8 is -3. So my last ordered pair is 4, -3. So now I'm going to go ahead and take my solution set, right? These 4 points that I got, and I'm going to put them on a graph because I'm asked to graph it. So my graph would look something like this. The point -1, 7, the point 0, 5, the point 2, 1, and the point 4, -3. So that's what my graph would look like for that good solution set. When you solve an equation for a given variable, that variable becomes a dependent variable. That is, its value depends upon the domain values chosen for the other variable. So let's look at example number 4, where we're asked to solve for a dependent variable. So we're going to refer to the original scenario at the beginning of the lesson where Eric has made a list of expenses he plans to incur while in England. We're going to use the conversion rate to find an equivalent US dollars for those amounts given in pounds and graph the ordered pairs. So this was what he came up with. And just as a reminder, this was the problem that we saw at the beginning of the lesson, right? Where he was trying to figure out how many dollars and pounds converted to each other, and we came up with this equation, right? P, the number of pounds, is equal to 0.69 times the number of dollars, and that allows us to convert from dollars to pounds. But in this one, we're trying to go from pounds to dollars. So what we're going to do now is we're going to take that equation and we're going to solve for D. We're going to get D all by itself because then it allows us to find out the dollars and input the pounds. So here's the original equation. We're going to solve for D. So D is currently being multiplied by 0.69. So we're going to divide both sides by 0.69 in order to get the D by itself. And when I do this, is like 1 divided by 0.69, which is 1.45 times P. So again, that's 1 divided by 0.69 gives me 1.45p approximately. This is rounded to the nearest hundredth. It actually is 1.45 something, 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 something. But we're going to keep it simple to 2 decimal places because we're talking about money. So now let's go ahead and plan this out. So now I've solved for my equation, right? I have D equals 1.45p. And they have these values here for the pounds. So I'm going to input these values in for P and find out what it equals to in dollars D. So let's go ahead and try that. So let's make a table. So here's my table, my pounds into my equation to find out how many dollars it equals, and then that's going to be my ordered pair. So my hotel is going to be 40 pounds. I'm going to plug it into the equation, right? 1.45 times P, or 1.45 times 40, which equals 58. So 40 pounds is $58. Let's try the next one. Meals are 30 pounds. Well, 30 pounds times 1.45 is going to give me 43.50. So that's $43.50. Next is 15 pounds for transportation. 1.45 times 15 is going to give me 21.75 or $21.75. And so there's my next one. And in this one, they just rounded to the nearest dollar, but this is probably more accurate to get right now. Finally, 6 pounds for entertainment. 1.45 times 6 pounds is going to give me $8.07 or $8.70. And so there you go. That would allow me to convert from pounds to dollars. So now I can go ahead and graph the ordered pairs. And it says, notice the values for the independent variable P are graphed along the horizontal axis, and the values for the dependent variable D are graphed along the vertical axis, right? So P are independent variable, and then D, dollars, are dependent variable. And here's the relation. Here are the ordered pairs. Let's examine. So if we look at the values in the range, the cost in dollars is higher than the cost in pounds. Do the result make sense? I think it does, because at the beginning we said that for every $1, it was 0.69 pounds. And so it would make sense that you were going to have more dollars than pounds, right? So it would make sense that the dollar amount is higher than the pounds amount. Thank you guys for watching. Let me know if you guys have any questions.